as well as actin. Now, more recently, and this is what we're going to hear about today, Sandy has been integrating various new biophysical approaches for dissecting this really important process within cells. In particular, she's used total internal reflection microscopy to look at
starting the next business unit.
Acidic vesicles, as well as planar supported bilayers to generate an artificial system where she can really dissect how all of this machinery is operating, in particular the role of cargo in regulating dynamic activity. Now, as a result of really this spectacular body of work that's characterized Sandy's work as a scientist, she's received many honors. She was elected, she was given the William Rose Award for the ASCMB. She's currently a fellow of the American Association of Advancement of Science. And most recently, she's been elected as the president of the American Society for Cell Biology. Now, coupled with all of this scientific and leadership role, Sandy has played a huge role in the publication arena in cell biology. She spearheaded the introduction of the journal, as a journal traffic, which is not new anymore, but she started it from scratch, and it was based on her superb running of that journal that she was then selected as editor-in-chief for the molecular biology of the cell, which she's only recently given up in lieu of her presidency to the American Society for Cell Biology. So I should mention that Sandy received her BS at the University of British Columbia, and then she got her PhD at Stanford, and then she postdoced at Yale with Ira Mellman before moving to Scripps in 1988, where she has been there since. Currently, she's serving the role of chairman of the Cell Biology Department there. So with that, I'd like to bring Sandy up to the podium, and she's going to talk to us about protecting our borders, regulated entry
around the mountainous
into
regions. Let's look at the weather transition. 9 a.m. in the morning. The weather will be quite similar to today. From Kyushu to Kanto, the temperatures will be about 25 degrees. The temperatures remain high even at night. And midday at about 3 p.m., temperatures will be very high from Kyushu to Kanto. And also Hokkaido, it covers 30 degrees centigrade, and inland areas 35 degrees centigrade and above. Temperatures remain very high. And Kyushu to Kanto, it could be about 25 degrees.
The plasma membrane is the barrier that protects
the regional forecast.
delicate intracellular environment from the heart extracellular milieu. It's also a sophisticated communication device. It's important to keep in mind. Signaling receptors on the cell surface are responsible for all of the communication of cell to cell, cells in development and motility, chemotaxis, physiological changes that happen. These are all mediated through communication at the level of the plasma membrane. It's also a dynamic port of entry. There are multiple endocytic pathways that govern nutrient uptake, surveying of extracellular milieu in the immune system, turnover of plasma membrane transporters in response to the physiological changes when you eat or when you have a high glucose in your bloodstream. All of these processes are being controlled by a myriad of endocytic pathways, each mechanistically distinct, and each one tightly coupled to and regulated by the specific cargo molecule that's being taken up by these processes. Today's talk is going to focus on plasma-mediated endocytosis, which is the major endocytic pathway in the cell's certainly the best understood endocytic pathway in the cell, and is involved in specific internalization of receptor and concentrative internalization of receptor ligand complex. Clathrin-mediated endocytosis occurs at specialized regions on the cell surface. In the background of this slide are electron micrographs taken by John Heuser that show the polygonal lattice of the clathrin coat that forms these clathrin-coated pits. The process involves the assembly of adapter molecules. Juan Bonifacino has studied them to great extent that recognize small, short sorting motifs in the cytoplasmic tails of receptors that are going to be concentrated in coated pits. These adapter proteins also trigger the assembly of clathrin, which is a self-assembling scaffold that forms into a polygonal lattice, helping to generate curvature in the growing vesicles. Here. The protein dynamin that we're going to talk about is targeted very early on during vesicle formation and eventually assembled at the neck. We'll talk a lot about that, leading to finally a fission reaction and the production of an endocytic clathrin-coated vesicle that carries a concentrated load of receptor ligand complex cargo into the cell. This spontaneous assembly of clathrin and adapters needs activity and energy to disassemble, and so the encoding agency is that I discovered as a graduate student in Jim Rothman's lab, since been studied in great mechanistic detail by Lois Green and Evan Eisenberg here at NIH, mediates an uncoding reaction to recycle code proteins for multiple rounds of endocytosis. In addition to these major constituents of the coated vesicle machinery, there's a plethora of other endocytic accessory factors, most of which have been identified through protein-protein interactions with adapters, clathrin, or dynamin, which serves as hubs in this systems biology type look at endocytosis by Harvey McMahon and his colleagues. Specific lipids are also required, and of course, the cargo is an important regulator. The question that one asks is, why is endocytosis so complex? Why all this myriad of accessory proteins when you compare it to vesicle formation from intracellular organelles that have been well studied by Jim Rothman, Randy Sheckman, Bill Balch, and others, where they have been able to reconstitute in vitro systems COP2 or COP1 vesicle formation using just the coat proteins, Sec2324, Sec1331, or the codomer complex, and the small GTPase, the SAR or R. So why the complexity of endocytosis at the plasma membrane? Now, you might argue it's because the plasma membrane is more rigid, it has higher cholesterol composition, it's got the underlying cytoskeleton, it's got the extracellular matrix. But I would say that there are multiple endocytic pathways that don't require this plethora of proteins. So rather, I would argue that the complexity reflects the need for strict regulation of these higher order communication functions of the plasma membrane. So key regulators of vesicle formation at each of these stages are members of the GTPase superfamily. The RAS-related GTPase, SAR, and ARF regulate vesicle formation at the ER and the Golgi, respectively. And the main gist of this talk is to tell you about dynamin, which regulates vesicle formation at the plasma membrane. So dynamin is both the brains and the bronze of clathrin-mediated endocytosis, and that's one of the main take-home messages of this talk. It was first discovered, its role in endocytosis was first discovered in 1973, actually at my alma mater, the University of British Columbia, by David Suzuki, who was conducting temperature-sensitive screening for chemically induced mutagenesis in flies. And he set up a screen for paralysis and isolated the Shibiri flies, this is Japanese for paralyzed, providing the first evidence for involvement of dynamin and endocytosis. Bing Zhang at UT Austin made this movie for me. These are mutant flies and wild-type flies being subjected to ever-increasing temperature. And you can see, as the temperature gets above 30 degrees, the mutant flies drop like flies. Whereas the wild-type are unaffected. This is a rapidly reversible phenotype. Jane Koenig and